Welcome. Let's look at the basics of matrices. First, matrices have to do with a way of showing information, and specifically a way where we can do calculations with that information. They are named based on the number of rows they have and the number of columns they have. We're going to be doing determinants, which calculate matrices down to a single number, and then we're going to use Cramer's rule to solve for variables based on using matrices. So take a look at this set of information, number of cars driving on some selected San Diego highways, okay, 8, 5, 15, and various days, and these are in thousands. You can make a matrix out of this by not using the categories. So we would put it as 300, 900, 600, 350, 1200, 800, and then so on. 400, 410, 250, and then fill in the rest. I'll do that really quickly here. And what we have are 3 rows and 5 columns. So since we have 3 rows and 5 columns, we have what's called a 3 by 5 matrix. Next idea to look at is doing a determinant. So we're going to look at 2 by 2 determinants and the specific pattern for figuring out the determinant. You think about the 4 numbers in terms of A, B, C, and D. And so you're going to do A times D, subtract B times C. Notice, by the way, that we're using the lines that are sort of like absolute value lines. They're not in this case. What they mean is find the determinant, as opposed to the brackets that is simply the information in the matrix. So the way we will do it here on this first one is we'll do 1 times 4 minus 2 times 3. So we get 4 minus 6, so negative 2 is the result for this first determinant. For the next one now, we're going to do negative 4 times 3 minus negative 2 times 6. Notice all the negatives. Yes, that's on purpose to practice them. Minus negative 12, so that's negative 12 plus 12. So this is the determinant of 0. And now the last one, 5 times negative 4 minus 3 times 1. So that's negative 20 minus 3. And so that gives us a negative 23. So those are some examples. Now for 3 by 3 determinants, that's next. There are 2 methods. There's diagonal and then a by minors. So I'm going to show diagonals on this case. So the first thing we do in the diagonals one is we take the first 2 lines and we rewrite them right afterwards. So now we have 5 columns instead of 3, and the last 2 columns are the same as the first 2. And then we leave a little space and we redo the whole thing over again. 1, 4, 7, 2, 5, 8, 3, 6, 9. Draw the line and then repeat these. What we're going to do is we're going to find the determinant of the first one and subtract from it the determinant of the second. But we're going to do the determinant based on diagonals. So we're going to do a diagonal of these 3. And then a diagonal of these 3 and a diagonal of these 3. And then on the other side, we're going to do a different direction diagonal. And we're going to multiply those. So we have 1 times 5 times 9 plus 2 times 6 times 7 plus 3 times 4 times 8. And then over here, we're going to do 7 times 5 times 3 plus 8 times 6 times 1 plus 9 times 4 times 2. And then we figure out the numbers. And then this is going to be subtracting all of these. So I suppose I should put this one in a big bracket or parentheses, extra parentheses. So now this first one, this becomes 45 plus 84, 12 times 7, 84, plus 12 times 8 is 96, minus 35, 15, 105, plus 48, plus 72. This is 225, take away 225, so the determinant is 0. And you get that from doing the first one minus the second one and using the diagonals. One direction for the first one and the other direction for the second, and then subtract. So what we're doing here is we're multiplying, adding, and subtracting. And it works if you follow these diagonals exactly that way. Let's take a look at the second method, which is expansion by minors. Minors means if this is a third 3 by 3 determinant, it's doing it as 2 by 2 determinants. So notice the A and B and C come from A, B, and C, and then all the other letters come from here. So what happens, let's do that. So for A, we're doing all 4 of the ones that do not connect with the A vertically or horizontally. Okay, and that's this one. For B, we're doing the ones that do not connect with B horizontally or vertically, only diagonal. So A and C are vertical to B, and E and H are horizontal to B, and E and H are vertical to B, and so we don't use those. And then for C, that's this set that are not vertical or horizontal to C. So let's work this out. Oh, and notice, by the way, that that one is negative. Sometimes you have double negatives on these things, so you have to be really careful with them. So let's set this up. This is A, and this is B, and this is C. So it's 1, 5, 8, 6, 9. That's from these here. And then minus 2. And for that, I'll use these two sets. 4, 7, 6, 9. Plus 3, and I'll use the ones on the first two, from the first two columns. 4, 7, 5, 8. And then at this point, we just simply multiply out what these are. That's 1 times 5 times 9 is 45, minus 48, minus 2. 4 times 9 is 36, minus 42, plus 3, 1 times 6 there. Then we have 32 minus 35. So we have negative 3. And this becomes, what, negative 6. Negative 6 and negative 2 is plus 12. And here we get negative 3 times 3 is minus 9. So that, again, here becomes a 0. Okay. Like it, really like it when some of these come out to a 0. Now here's another one. Okay, do this one yourself. Turn off stop the video and then come back to it when you're ready. I'm going to go ahead and do it so you can see it after you come back to it. Okay, I'm going to set this up with the 8, 6, 7, 3, and -8, minus -4. I'm careful with the parentheses. 5, 3. I need the line between them. 5, 3, 3, and -8, plus 7, 5, 3, 6, and 7. See if those make sense and I got them in the right places, because it is easy to sometimes put the wrong number in places. So that's 8. All of that comes to -69 plus 4. All of that is -49 plus 7. That's 17. So that's -552 minus 196 plus 119 comes to a total of, not put equals here, equals -629. That's the determinant for this 3x3 matrix. Now let's look at an example of Cramer's rule. There's a specific pattern that you follow, and that pattern has to do with the coefficients of the x, y, and z terms. When you take just those coefficients, you get this matrix, which we'll call the C matrix. Okay. And then for the x value, notice what we're going to do here is we're going to use the results, the answers for each of those equations, in place of the x's. Otherwise, it's the same coefficients. And for the y's, we're going to do the same thing, but it's going to be in the middle where the y's were, the coefficients for the y values. And then for the z, it's putting the coefficients there where the z's are. All right, now let's take a look at the, I have the coefficients of 2, -1 and 1, 1, 2, and 1, -1, 1, and 2. Oh, and I need to do, that's the matrix for it. I'm going to change those to the line saying, let's do the determinant of that. Okay, and that determinant is going to be 2, 2, 1, 1, 2, minus 1, minus 1 and 1, 1 and 2, and then minus 1, minus 1 and 1, 2 and 1. So that's A and B and C. Okay. And here was A and B and C, so I took those, and then the bottom ones for the minors. And when that multiplies out for minus 1, 5 times 2, keep working all this out, and you get the number 12. So this, the C, actually, let's write that a little better for that. The C matrix is 12. I don't know why they call it a C. Consonant, maybe? Oh, but we'll accept that right now. Now we're going to find the determinant for the x. And what that's going to do is require us to do the same type of determinant here, except that this column will be different. So equals, let's put in that second column and third column. And in this place, we're not going to use the 2 and -1 and 1 that were the coefficients of the x. Instead, we're going to use the answer parts for each of the equations, the right side solute or answers to it. So now I'm going to put in -2, -0.5, and 3.5. And then we're going to find, I'll do it by minors here, we're going to find the determinant for this x1. -1, so that's A, here's B, and here's C. This is A and B, -1, -0.5, oh, I don't need a slash there, it's just 0.5, and 1 and 2, and then -1, that's the C, -0.5 and 3.5, 2 and 1. Now when we calculate that, that's equal to 6. So the x determinant is 6. So now x is equal to the x determinant over the c determinant. So we have 6 over, we got 12 before, is equal to 1/2. So what we have right now, 1/2 of the x. We need to find out what the y and the z are to finish out the three things, the x, y, and z. And to do that, we'll go to the next page. So we're going to find the y and z values. The concept here is going to be the same. For the y function, we are going to do, or the y determinant, we're going to use the x determinant, or the x coefficients, not the y coefficients. We're going to use the -2, 0.5, and 3.5. But we will use the z determinants, -1, 1, and 2. And now I'll do this one by minors. 2, -0.5, 3.5, 1, and 2. -2, -1 and 1, 1 and 2. -1, -1. Oops, I just made sort of a mistake here. That's -2. Make sure that I did that right in writing it up here. I did. So this one, I did the -1 there. Okay. On this one, I have to make it minus the -2 because that's the b, but it's subtract b. Okay. And then -1, 1, 1, and 2. Nope, not 1 and 2 because it's the z1. So it's -0.5 and 3.5. What I was doing, I was looking at these for the z1. And then the answers for those, and this one I'll work out, is -1 minus 3.5 plus 2 minus 2 minus 1 minus 1 minus 3.5 plus 0.5, because these two negatives, 2 -4.5 plus 2 -3 minus 1 -3. So we get -9, -6, and 3, which comes to -12. So the y determinant is -12. That means now if I do for y, that's equal to the y determinant over the c determinant. So it's -12 over 12, which is -1. Going to come back up here. I'm going to put -1 there for the y. And now let's do z. And that one in black here. So the z determinant, I'm going to use the x coefficients and the y coefficients, but then I'm going to use the answer on the right side coefficients. Okay. And then I'm going to do this one out here by equals 2 by minors, 2, 1, -0.5, -3.5, -1. B is 1, so it's minus that one. That 1, -0.5, 3.5, -2. So it's C, and it's already negative. -1 and 1, 2 and 1. So these ones, I can state that this comes to 15. This all comes to 3. And this all comes to 6. So I have 15 plus 3 plus 6 equals 24. So the z determinant is 24. And if I want to know what z is, that's equal to the z determinant over the c determinant, which is 24 over 12, or 2. So let's come back up here and put 2 in there. Let's see if everything stays and I can fill this in. Oh, no, get back there. Okay, and now you see how to use Cramer's rule to get the solution for a system of equations, in this case a system of 3 equations. So we start off with a series of equations, and we can use the determinants to find x, y, and z. In this case, 1/2, -1 and 2 for x, y, and z. Using, in this case, expansion by minors, but expansion by diagonals would have worked as well. Okay. I hope this helps to understand these things, and thank you for watching and listening.